Hey everybody, Andrew here again, and in this video we are taking a look at question number 47 from the math test in test 2 in your red book. Take a second, pause the video, flip to number 47 in the math test, in test 2, read the question, and then hit play. Alright friends, I'm going to keep this short and sweet. If you haven't taken a statistics class before, or a English class, either. If you haven't taken a statistics class before, this problem is going to look like gibberish to you. You might not have seen this symbol before. You may have never seen this kind of mathematical language before. And if you haven't taken a statistics class, haven't seen this before, this problem is going to be really difficult to answer because you don't know the stuff you need to know in order to answer the question. So if that's you, remember this is the type of question that you don't want to let it suck your brain power out. You don't want to spend a whole bunch of time on this thing. You don't want to camp out on this problem if you know you're not going to find the answer. So this is not low-hanging fruit. This is one that maybe you should skip. But if you have taken a stats course before, this might be a walk in the park. So all I want to do is give us a quick reminder here. It's asking about this statement. This reads like this. If I was going to say this in English, this is what it would say. The probability of A and B. The probability of event A and the probability of event B. What's the probability that both A and B occur? And the answer choices give us ways, different formulas of how to calculate this. And if you know the definition of this, you can answer this problem, this question. If you don't know the definition of this, you can't. So let's think about this simply, really quickly. Let's say I ask you, what's the probability that you flip heads when you flip a coin? Obviously, the probability is 1/2. What's the probability that you roll a 1 on a 6-sided die? Well, the probability of doing that is 1/6. Now let's say I say to you, imagine you flip a coin and you roll a die. What's the probability that you hit A on the coin and 1 on the die? Well, what you do is you take the 1/2, the probability that you flip heads, times 1/6, the probability that you get a 1. So imagine, they're completely separate events. The coin flip and the dice roll are completely separate events. But if I want to know what's the probability of both of them happening, whether you know it or not, whether you know this language or not, you know to multiply the two probabilities together. So let's call this event A and this is event B. Flipping the coin is event A. Getting heads on the coin is event A, and 1/2 is the probability of event A. Getting a 1 on a die is event B. 1/6 is the probability of getting a 1 on that die. So you'll notice, what did we do here? We multiplied the probability of event A times the probability of event B. And so here's the definition of this weird looking math language. Anytime you see something like this, the probability of event A and event B, this is the same thing as probability of event A times the probability of event B. This is just the definition that you would learn in a stats class. So if you've seen this before, great. This might be an easy problem for you to answer. The answer is D, probability of A times probability B. If you haven't seen this kind of denotation before, this might be a really difficult problem and it's okay to skip. Either way, the answer is D.